A function f is defined by fx is equals to e to the power of x times cosine x, where the x is anywhere between 0 to pi over 2. By using calculus, find the stationary point of the function of x and determine its nature. So first let's copy down the function x. So function of x is given as e to the power of x times cosine of x. So take note, so cosine of x must be between 0 to pi over 2. So now, of course, when we want to find the stationary points, we need to differentiate with respect to x. So let us find the f prime x. So f prime x is equals to, there are two functions, one is an exponential function, the other one is a trigonometric function. Therefore we're going to use product rule to find the f prime x. So let us keep the e to the power of x fixed, and when we differentiate the cosine of x, it's going to become minus of sine of x. So we have kept the e to the power of x fixed and we have differentiated the cosine x. Now we need to keep the cosine of x fixed and differentiate e to the power of x. So let's keep the cosine of x fixed, and what will be the value if we differentiate e to the power of x? Of course, it will become e to the power of x. Now we can see that in this term there is a e to the power of x. Here also we have e to the power of x. We could factorize and take out the e to the power of x. So we can take it outside a bracket, and what we're going to have is cosine x minus sine x inside the second bracket. So there we have the first derivative of the function of x. Then of course we also need to determine the nature of the turning point or the stationary point. So in order to do that, we need to differentiate it once more in order to find f double prime x, so that we know if it is less than 0 or greater than 0, so as to determine whether it's a maxima or a minima. So let us differentiate again, and once again we can see, if you want to differentiate once more, we can see that there is a couple of functions in either of the brackets. One is an exponential function, the other one is trigonometric function. So let's do the f double prime x. So as always, we are going to keep the e to the power of x fixed, and then let us differentiate what is inside the bracket, second bracket. So cosine x, if we differentiate, it's going to become negative sine x, and of course sine x, we differentiate, it becomes cosine x, but this negative sign we just carried out. So when we kept the e to the power of x fixed and differentiated cos x minus sine x, we get minus sine x minus cos x. Now we are going to keep the cosine x minus sine x fixed and differentiate e to the power of x. So let's keep the cosine x minus sine x fixed, and let us differentiate the e to the power of x, which is of course going to become e to the power of x. So once again we can see the e to the power of x is a common factor. So let us pull that out. So we have e to the power of x, and everything else, let's all the trigonometric function, let us put it into the second bracket. So we will have minus sine x, okay, and minus cos x. From the second bracket we have got the plus cos x and then a minus sine x. And what do you notice about this? Okay, here we have a minus cosine x and a plus cosine x, which would of course be able to cancel. So what you would have is e to the power of x, and if we cancel the minus cos x and the plus cos x, we are just going to be left with minus sine x, which of course is minus 2 sine x. So we can bring the minus 2 to the front and write it as minus 2 e to the power of x sine of x. So there we have the second derivative, which will enable us to determine the nature of the turning point. Now let us work out what is the x coordinate of the turning point. So in order to get the x coordinate of the turning point, we need to equate the first derivative to 0, because at the turning point f prime x should be equal to 0, or dy dx should be equal to 0, as you know. So e to the power of x is not possible to be 0, because e to the power of x is always a positive value. Therefore if f prime x ever became negative, it is because of the second bracket. Cosine x minus sine x must have been equal to 0. Since e to the power of x is always positive, so it must be cosine x minus sine x, that must have been 0 in order to give the first derivative as being equal to 0. So for what value of x would this cosine x and sine x be equal, or cosine x minus sine x would be equal to 0? If I were to throw the minus sine x to the right side, it's going to become positive sine x, And if we take sine x and we divide it by cosine x, okay, that's going to give us a tangent x. And of course, once I bring my cosine x over to the right side, so the left side would simply become a 1. So we will get tangent x being just equals to a 1. And what would be the, at what value of x would tangent be equal to 1? So x should be of course equals to arctangent of 1, which should be 45 degrees or pi over 4 radians. Okay, and of course we do not need to worry about subsequent values, because x has got to be between 0 to pi over 2 only. So x must be between 0 to pi over 2. So therefore x is pi over 4. When x equals to pi over 4, cosine pi over 4 minus sine pi over 4 would become root 2 over 2 minus root 2 over 2, which is of course going to become 0, and that would turn f prime x equals to 0. And so the x coordinate, okay, of pi over 4, okay, would give the x coordinate of the stationary point. Now we need to find what is the y coordinate of the stationary point. Let's take the x equals to pi over 4 and replace the x in the function of x. So f of pi over 4 should be equals to e to the power of pi over 4, okay, which I have written here, and then cosine of the pi over 4, right, pi over 4 radians or 45 degrees. And e to the power of pi over 4 is just going to stay as e to the power of pi over 4. Cosine 45 degrees is a special angle, or cosine of pi over 4 should simply be 1 over root 2. And of course you can rationalize it, and you can write it as root 2 over 2 times e to the power of pi over 4. This would be the y coordinate of the stationary point. So therefore pi over 4 is the x coordinate of the stationary point, and root 2 e to the power of pi over 4 over 2, okay, should be the y coordinate, and this is the coordinates of the stationary point. Okay, so we have done half of the problem. We need to now state what is the nature of this turning point. So to do that, okay, we're going to take the x coordinate, which is pi over 4, and substitute into the second derivative, okay, f double prime of pi over 4. So let's put it all the x with a pi over 4 and see what happens. Okay, negative 2 e to the power of pi over 4. So I have replaced the x with the pi over 4, and sine of pi over 4. Okay, once again sine of pi over 4, okay, it's actually root 2 over 2, which is a positive value, and e to the power of pi over 4 is also going to be a positive value, and positive value times positive value is of course going to become positive. And when we multiply that by a negative 2, okay, so the whole of this number would become negative, so it will be less than 0. And of course what it means, when the second derivative of the function is negative, it implies that it must be a maxima. So there we have the nature of the turning point. Now let's look at the part B. Okay, we are given a function fx is defined as e to the power of x cos x. Integrate by parts twice to show that e to the power of 2x times cosine of 2x dx should be equals to a quarter of e to the power of 2x times sine of 2x plus cosine of 2x plus a constant of integration c. So we have e to the power of 2x times cosine of 2x. So because when we want to differentiate this, so we need to have a 2 in front, right? So I am just introducing a 2 here, and I am putting a half outside, so which is effectively exactly the same as this, because if we cancel the 2 and the 2 here, it will be the same as this. So I am just taking a half outside the integration symbol. So now we can actually start to do integration by parts. So let my u be cosine of 2x. Okay, I'm just going to write that here. And of course my other function, which is 2 e to the power of 2x, is going to be my dv dx. Okay, 2 e to the power of 2x. Now if u is equals to cosine 2x, so we want to find what is du dx. So du dx means we need to differentiate cosine of 2x, and of course when we differentiate cosine of 2x, you're going to have a 2 in front, and cosine 2x, if you differentiate, it's going to become minus sine 2x. So it is simply going to become minus 2 of sine 2x. Now if dv dx is equals to 2 e to the power of 2x, and for this you need to integrate it to find the v. So your v would be equals to, if you integrate 2 e to the power of 2x, it is simply going to become e to the power of 2x. So there we have u, v, du dx and dv dx. So we can just substitute every value here into the standard formula, okay, using the integration by parts. U times dv dx times dx should be equals to uv minus v du dx dot dx, right? So we have the half outside, so let's keep the half outside here, and now we're going to put in what is our u and dv dx, but of course I'm going to write the dv dx first, or you can write the du dx, I mean u first, and then you can write your dv dx, which is 2 e to the power of 2x dx. You can see this is exactly the same as what we have here, right? Half 2 e to the power of 2x is just that the 2 e to the power of 2x is written in front, at the back here, and the front here, and the cosine 2x is written at the back here and in the front here. And then now let us substitute, okay, what is u and the v. Remember to put in the half, okay, because the half is outside the integration symbol. So I'm going to write the half and enclose the rest of the things in a braces. So we have an open brace, and then we are going to put in what is our u and v. So we have got our u here and we got our v here. So let's take the u, which is cosine 2x, and our v is e to the power of sine 2x. So there we have the u times v minus integral of v, okay, our v is e to the power of 2x, and our du dx is minus 2 sine 2x. So I've written my v here, and then my du dx, which is minus 2 sine 2x, okay, dx. So there we have it. So we have already substituted, and let us now distribute the half and do a little bit of tidying up. So half times cos 2x e to the power of 2x would simply be e to the power of 2x times cosine 2x divided by 2. So I have distributed the half for the first term. Now let's take the half and throw it in for the second with the integration symbol. So I'm going to just put it here, but before that we can see here there is a minus sign in front of the integral, and there's also a negative sign inside. So if I pull out the negative and the negative, okay, it's going to become positive, and that's why I have the positive. Now let's, you know, distribute the half here. So half integral, okay, since I have already pulled out the negative sign outside to turn it into a positive. So what we're going to have inside the integration symbol is going to be a 2 and then e to the power of 2x and then the sign of 2x, okay, integrate with respect to x. So that is the next step. So now let's keep this step over here and let's work on it further, right? So this part we are not going to do anything, e to the power of 2x cosine 2x over 2, and then here we have the half, okay. Now for this part, okay, we need to do integration by parts once again. That's why the question indicated that integrate by parts twice to show that, okay. So even if they don't tell you that, this is exactly what you need to do. You got to do it once more. So let our u be, okay, sine of the 2x. We keep the trigonometric function as a u, and since 2 e to the power of 2x is easily integrable, so we're going to keep that as the vx, and then let us differentiate the u to get our du dx. Sine 2x, if we differentiate, it become 2 cos 2x, and dv dx is 2 e to the power of 2x, and if we integrate it to get our v, it should be simply equals to e to the power of 2x. Now we can start to put in all the values. So when you want to integrate this, it's going to be u times v. So we have the sine 2 e to the power of 2x times sine 2x. That will be the u and the v. So that's my u, and my v is e to the power of 2x, and then minus, let's put in the integral symbol, and then we need to do v times du dx. So that's my v e to the power of 2x, and my du dx is 2 cos 2x. That's what I'm going to put in there, and then write the dx, and let's close it with the braces, right? So now let us continue further. So e to the power of 2x cosine 2x, I'm not going to do anything with this, but this part I can just distribute the half, so, and also put the e to the power of 2x in front. So it will become e to the power of 2x times sine 2x, and then because of the half it's over 2, and the half I have also brought it in front of the integral symbol, that's the half over here, and whatever that is inside the integration sign I'm still keeping it, but I just managed to rearrange it. So I brought the 2 and put it together with e to the power of 2x, so we get a 2e to the power of 2x times cosine of 2x. Now if you look at these two brackets, these two fractions, we can see both of them have got the common denominator of 2, and both of them also have e to the power of 2x, so we could combine and factorize them at the same time. So I put in a 2, since e to the power of 2x is common to both of these numerators, so I pull it outside the bracket and I have cos 2x plus sin 2x minus, and then I've got my half here and the 2 here which I could cancel, right? So I will just simply have minus e to the power of 2x cosine 2x dx. Now I want you to take note, okay, this and this, okay, looks exactly the same. So what we need to do now, okay, so we have got integral of e to the power of 2x cosine 2x dx here, and we also have integral of e to the power of 2x cosine 2x dx over here, and of course this is with a negative sign. And if I take this entire thing and I throw it over to the left side, okay, there's going to be 2 of this, so it would become twice of e to the power of 2x times cosine 2x dx. And since I have already brought this over to the left side, so what we're going to have is on the right side is simply e to the power of 2x times cos 2x plus sin 2x over 2. So now this is a multiplication by 2, and if I throw it over to the other side, it's going to become division by 2. And if the 2 and the 2, if we multiply together, the denominator on the right side is going to become 4. And of course we have to write the constant of integration c. So this is exactly what we are told to show, and of course we have shown that, and if you did it right, so you would get 4 marks for this section B, part B. Right, now let's look at the part C. So part C says, okay, the graph of y equals to fx is rotated completely about the x-axis, and the question expects you to find out the exact volume generated. So how do we do that? So this is my x-axis and my y-axis, and if we substitute x equals to 0, so cosine 0 is going to become a 1 times e to the power of x, e to the power of 0 would be a 1 if you multiply by cos 0, which is also a 1 times 1 is going to become 1. That's why when x is a 0, y would be a 1, and when x becomes pi over 2, okay, so pi over 2 is of course is 90 degrees, so cosine of 90 degrees is going to go to 0, so 0 times anything is going to become 0, so this would be the x-intercept. And if you were to sketch, so this is how your y equals to e to the power of x cosine x graph is going to look like. Now this graph is rotated completely about the x-axis, so if you were to spin this about the x-axis, so you're going to get this shape, okay, like a shape of a bullet head like that, okay. Is rotated completely about the exact x-axis, and you're expected to find the exact volume generated. So how do we find the exact volume generated? Let's take a small little disk, okay, from the region that we want to find the volume. And if I were to take that disk, and what would be the radius of the disk? The radius of the disk will be of course along the vertical line, which is of course the value of y, and the small thickness will be in terms of x, so let's call it delta x or dx, right? So this is the radius and this is the height. So the formula for volume of a cylinder is going to be pi r square h. So pi times the radius in this case is going to be y, so pi times, then you have a y, pi r squared means pi y squared, times the height, which is dx. And of course we have to add such small disks from the value of x from 0 right all the way to when the value of x becomes pi over 2, which is here. So this is the integral, but we can't integrate y square with respect to x, so of course we need to integrate x, function of x in terms of x. So but what is my y? Y is e to the power of x cosine x, right? So we just need to square it and replace the y square with this. So Okay, I have replaced the y with e to the power of x cosine of x as given by the question, square times dx. Now let us distribute the square sign. So it is going to be e to the power of 2x, because e to the power of x square will be simply e to the power of 2x, and cosine x will also become squared, so it becomes cos square x. So now the next thing to do would be, okay, we have got e to the power of 2x, the cosine square x, let us replace in terms of using the cosine double angle formula. Okay, cosine double angle formula, you should remember, cosine 2x is equals to 2 cos square x minus 1, and that is what I am using. And of course, if you manipulate it, cosine square x in terms of cosine of the double angle cosine 2x, and this is what you should get. So replace the cos square x with 1 plus cosine 2x over 2. So now e to the power of 2x, and we have got a 2 here. So this 2, since it is a constant, okay, it would make more sense to take it outside the integration sign. So I am just going to pull it out. So put it outside the integration sign, pi over 2, because both of them are constant. And what I am going to have inside the integral is e to the power of 2x times just the numerator 1 plus cos 2x dx. Now let's continue further. So we have got this, and then let us now expand this, okay, bracket, so that we could make use of what we did earlier. So e to the power of 2x times 1 is simply e to the power of 2x, and then e to the power of 2x if I distribute in front of the cosine 2x, so I'm going to have e to the power of 2x cosine 2x dx. So what's the next step? Let's split this up, okay. So pi over 2 e to the power of 2x dx plus, let us now throw in the pi over 2 again. So pi over 2 e to the power of 2x times cosine 2x dx. Now this is quite easy to integrate. So e to the power of 2x, if you want to integrate, so you can introduce a 2 here, because when you differentiate the 2x there should be a 2 here. So it's okay, you can introduce a 2 here, and outside you multiply by a half. So pi over 2, if you multiply by a half, is going to become pi over 4. And then for this side we have got a pi over 2, and this one is from the earlier part, okay, from the part B we have already shown e to the power of 2x cos 2x. Okay, when we integrate it, okay, from integrated, it simply becomes e to the power of 2x cosine 2x plus sine 2x over 4. Of course we had a plus c, but when we do definite integral we can ignore the plus c, because there's no point for you to write a plus c and then subtract away a minus c, right? So we can just take this from part B and we can just write this down. Now all that we need to do now is to integrate 2 e to the power of 2x. When you integrate it, it simply become e to the power of 2x taken from pi over 2 to 0, or 0 to pi over 2. And then on the other side we have got a pi over 2, and this is a constant, so it would make more sense for you to pull out the constant and write it as pi over 8, so that we can just use the numerator alone. Okay, e to the power of 2x times cosine 2x times plus sine 2x, and the limits remain 0 to pi over 2. So now we have got a pi over 4 here, and we have a pi over 8 here. So if I could just pull out some common numbers out of this, okay, which would be of course pi over 8, then we can just write it as one single expression, and it will be easier to simplify. So I'm just going to take out a pi over 8 out of this. Of course, if I want to take out a pi over 8, so I have to introduce a 2 in front of the e to the power of 2x. So 2 e to the power of 2x, and then from this I have taken out the pi over 8. So what I will have is e to the power of 2x times cosine 2x plus sine 2x. Okay, now since this is also 0 to pi over 2, this is also 0 to pi over 2, I can combine it and write the limits as a 0 to pi over 2 for the entire expression. Now the next step would be to simplify this. Okay, we have a 2 e to the power of 2x, and here also we have got a e to the power of 2x. So I'm just taking out the e to the power of 2x, okay, out of this and this, so that the 2 is brought into the bracket. So 2 plus cosine 2x plus sine 2x pi over 2 to 0. So now we can just start to substitute the pi over 2. So pi over 8, e to the power of twice of pi over 2 is simply going to become e to the power of pi, okay, 2 times pi over 2, and cosine of 2 times pi over 2. 2 times pi over 2 is going to become pi, and cosine pi would of course be -1. And then this part is going to be sine pi. Sine pi is of course 0. Then we have to substitute the lower limit of 0. E to the power of 0, twice of 0 is 0. And then we have cosine twice of 0 is a 0. Excuse me. And sine twice of 0 would of course be equal to 0. So let's write the pi over 2. So 2 and 2 if we cancel, we would have e to the power of pi, and then 2 here, and cosine 2 and 2 if we cancel, it becomes cosine pi, and cosine pi is of course cosine 180 degrees, which is -1. I have put in here. And the 2 and the 2 if we cancel, it's going to be simply sine pi. Sine pi means sine of 180 degrees, which is of course equal to 0. And then this minus sign is what we have here. What is e to the power of 0? Anything to the power of 0 should be a 1. So 1 times anything is going to be just the same thing. So that's a 1. And this 2 is here. And cosine 0 is a 1. So I've written a 1. And sine 0 is of course a 0. So that's what we have now. Now all that is left of us to do is to simplify. So we've got a pi over 2, pi over 8. So we have got e to the power of pi. 2 minus a 1 is going to become 1. 1 times e to the power of pi is simply going to become e to the power of pi minus 2 plus 1 is a 3. 3 times 1 is a 3. So it is just a -3. So that is the simplest that we can bring it to, and we can rewrite it as pi over 8 times e to the power of pi minus 3 over 8 unit cube. And that is the exact volume generated when the graph is rotated completely about the x-axis.